Hello and welcome to another video. In this video we're going to be working on first missing positive, and this is very similar to the duplicate numbers problem we did yesterday. So in this one you're given an array of integers and you want to return the smallest positive integer that's not present in here, starting at 1. So 1 is in here, 2 is in here, 3 is not, so you return 3. Then in this one, 1 is in here, 2 is not, so return 2, and 1 is not in here, so return 1. And this is very similar to the one yesterday. So what we can do is for every number, we can just correlate it to an index, and then we can manipulate the input to kind of mark if we visited it. So let's walk through what I mean. So first of all, what we can do is for every negative number or for any number that is bigger, like let's say we have an array of length 4. So if we have an array of length 4 and the number is like 5 or something, that number doesn't really matter. Like the only numbers we care about are 1 through 4. So if 1 through 4 are in here, those are the ones we care about. Because if one of these is like 5, that means there's a number 1 through 4 that's missing. So any number that's bigger than the length of the array, we don't really care about, because that number will never be the answer. Similarly, every negative number will also not be the answer. So what we can do first is we can take our initial array and just turn every number that's bigger than the length of the array or negative into a 0, the way that I'm going to have it. So we're going to have 3, 4, 0, 1. Then what we can do is kind of similar to the last one. We can just find some big number. So because the biggest number you can have here is this, but like I said, any number that's bigger than the length of the array, we can just ignore, right? So any number that's bigger than the length of the array will just turn into 0. And so then what we can do is the biggest number in our array, the most it can ever be, is the length of the array. So then we can just make some constant that's like the length of the array plus 1. So in this case, we'll call this constant like b or c or whatever, and this is going to be 5 in this case. Then what we can do is for every single one of these numbers, this will map to an index. So, and we want this to be 0 indexed, because an array is 0 indexed and these numbers are 1 indexed, right? So in this array, if everything existed, it would just be like this, right? It would be 1, 2, 3, 4 in some order. And so because if that's the case, then if the indices are 0, 1, 2, 3, we can just take the numbers and subtract 1 to get the actual location. But we might have already added this number to one of our numbers. So if we add this to one of our numbers, that means we've visited this index. That means this number exists. And I'll kind of walk through and show you what that means. So let's walk through this example. And then yeah, that's fine. Okay, so in this example, so we have 3, 4, 0, 1. So we're going to start the first number. And we're going to say, okay, first of all, we want the true number that was in here. So if we did add this thing, we don't want the number plus this thing. We want the true number. That's pretty easy to do. You just take your number modded by this constant. So in this case, we're going to get 3. Then we are going to subtract 1 because we want the 0 index. So our index here is going to be 2. So we want to mark index 2, which is, let's mark like this. We want to mark index 2 as visited. And we can't use visited, so the way we'll mark visited is by adding this number. So we will say this number is, instead of 0, it is 0 plus c. So this is c. Then we'll go to the next number. And we do the same thing. First we mod it by c because c might have been added to it. And so in this case it's not. So this can be 4 minus 1 because we want a 0 index. So this will be 3. So that means we visited this thing. So this, we need to add c to it. And we don't need to add c multiple times. So what we can do is we can take whatever number is in here, mod it by c to make it like the original number, and then just add c. So in this case, we'll just have 1 plus c here. Then we'll go to the next number. And we're going to say, okay, this is c, but what's the original number? It's this number modded by c, which is 0. And 0 minus 1 is the location, which is -1. So because this location is invalid, we can just ignore it. Like we can't go to -1. So this will be ignored. So every number that's 0 means it's an index that we don't care about, because those are the numbers we don't care about, right? We don't care about numbers 0 or numbers bigger than the length of the array, because the answer is never going to be any of those. So we're going to go to the next one. Then here we're going to say, okay, we have 1 plus c. We want to mod by c to get the original number, so we'll get 1. We'll subtract 1, we'll get 0. 0 is valid index, so we want to mark index 0 as visited, and by doing that, we'll just add this constant to it. So we will add this constant. And now we can just go through our numbers again. And we can just say, okay, if this number is not bigger than C, that means this number hasn't been visited. And remember, this 0 represents 1. 1 represents 2, 2 represents 3, and so on, right? Because this is 0 index, but they're represented 1 index numbers. So we're going to check, okay, so this is visited, so this is fine. This number is bigger than C. This number is not bigger than C. So that means 1 hasn't been visited. And I think I did that wrong somehow because there should be... Oh, right. So 1 hasn't been visited, but remember this 1 represents a 2. So remember these indices represent the actual number that's 1 indexed. So like 0 represents 1, 1 represents 2, 2 represents 3, and so on. So this hasn't been visited, so we just return this index plus 1. So we'll return 1 plus 1, which is 2. And that's the answer. And that's basically how you do this problem. You just, instead of marking it visited, you can just add this constant to every single number that you visit. Then you just check, is my number bigger than the constant? If yes, I visited it. If not, I haven't. And the first number that you didn't visit is the one you return. And let's say this whole thing was visited. Like, for example, if these numbers instead of this was like this, right? So if this was 1, 2, 3, 4, then all of these would be marked because 1 would point to 0, 2 would point to 1, 3 would point, and so on. Then all of this is visited. So then that means that 1, 2, 3, 4 visited. So then you just return the 1 right after those. So if you didn't return anywhere in the array, you just return the length of the array plus 1 because that's guaranteed, right? Like if an array of length 4, either 1 through 4 will be missing, or if 1 through 4 are in here, then 5 has to be the answer. That's why I said if your number is 5, 5 can never be, if 5 is in the array, 5 will never be the answer because that means one of these is missing. And so that's basically the idea. So let's recap the steps. First, we take every number that is bigger than the length of the array, or less than 0. We make it 0 because we don't care about those. Then for every number, we figure out the location to go. The location is that number modded by this constant minus 1 to make it 0 indexed. To that location, we add C. But first, we mod that number. We can't just keep adding C. That's also fine. But I'm just going to mod it by C and add C to make sure that I only added C once. It doesn't really matter. Either one's fine. Then we do a second iteration where we look for... So I guess we technically do 3 loops, but it doesn't matter. It's a linear time. So first loop, take everything, turn it to 0. Second iteration, add the constants correctly. Third iteration, whichever number isn't bigger than a constant, return that, or return the length of the array plus 1. And that is what we will code up. So like in this example, it's pretty easy to see that this will refer to index 6. This will refer to index 7, 8, 9, 10. Or sorry, it would be 6, 7, 8, 10, 11, which means index 0 won't be visited, so we just want to return 1. And similarly, this thing, this will be not used. This will refer to index 0, so that'll be visited. This will refer to index 1, and so index 2 is the first one that's not visited. And remember, this is 0 index, so we want 1 index, so it's going to be 2 plus 1, and we return 3. So let's do the solution in Java. So first, we'll make a constant for like our big number we're adding. So let's get a couple numbers here. Let's first get like the length of our number. So let's just call this like n or something. And this is going to be num's length. And so the constant we can add, let's call that like c, is just going to be num's length. Let's see here. Yeah, we can just do like num's length plus 1 or something, right? Because every number in the array, like if it's an array of length 4, we want to add 5. So it's just num's length plus 1. You can add something bigger, but this is like the smallest number that you can add to make it work. Then we want to loop through our array. Every number that's bigger than n or less than 0, we can turn into 0. So we can say for int I equals 0, I is less than. We'll have like 3 loops, so we can just copy this a bunch of times. Length plus plus. We can say nums I, or sorry, if nums I is less than 0, or nums I is greater than n. We don't care about those. We'll just make them all 0 to make it easy for us. Because like these numbers can get really big, so we can just turn into 0 so we don't have to add something too big. So like this is not needed, like because the numbers can be really big, we can just turn all those into 0s. So nums I, we'll just make it 0. Then we need 2 more loops, so let's just copy this and then write our loops. So this loop, what we need to do is first we need to get a location. So the int location is going to be nums I modded by c, right? Because we could have already added this constant. We want the original number. The way to do that is mod by c. And then we want to subtract 1 to make it go from 1 index to 0 indexed. Then we want to say nums location equals nums location, same thing, modded by c, so we don't keep adding c to it. And then we add c to that. So plus c. Then we loop through this, and we say if nums I is greater than c, that means we've visited it. I'm trying to think if it's greater or if it's equal to c as well. I think equal as well, I want to say. Oh, no, it's the other way around. If we haven't visited it. So if it's less than c. Yeah. So like these numbers, if you go back to our original example, this number is less than c. So if the number is less than c, then that's the one that's missing because we haven't visited it. So if nums I is less than c, then we want to return that number. But remember, we don't want to return the number. We want to return the index. But remember, 0 index is number 1 and so on, right? Like this refers to 1, this refers to 2, 3, and 4. So we can return I plus 1. And if we go through this whole array and everything is visited, then we just return n plus 1 because that's the next missing number. So like if an array is length 4 and 1 through 4 are present, that means the answer is 5. Let's see what we get. Let's see what our error is. Out of bounds. Oh, right. So when we get a location, we have to make sure our location is valid. So if our location, if our location is -1 or something, then it's not valid. So we can say if location is valid, which means location is greater than or equal to 0. I don't think it can ever be, I want to say it can never be too big, so we don't have to care about that. I think it's this one's just fine because we made all the bigger numbers equal to 0, but let's see what happens. So if the location is, if this number was 0, then we will get -1. So as long as it's not -1, I think it should be valid now. Let's try it. Okay, nice. Yeah, and as far as runtime, I mean, I did use three loops, so if you use less loops, it'll be faster, but it's all the same thing. It's also, it's hard to compare 2ms to 3ms to 1ms or something. But yeah, so this does modify input. I think there's another weird thing you can use, some kind of sort thing that doesn't modify input, but I think this is pretty good. So, and they didn't say you can't modify input. I know normally it's bad, but when they give you all these constraints, I think it's a little bit more reasonable when they say you can't use extra space or any of these things. So in any case, so this is going to be, let's write this stuff. So time will be O of n because we're looping 3 times, and space will be O1. So yeah, that's going to be all for this one. As usual, if you have any questions, just feel free to ask me. But yeah, this is a very similar problem to yesterday. Not too bad. This one is, I guess you can also technically make numbers negative if you visit them. You can change this a little bit. Maybe any number that's irrelevant, turn it into something weird. Instead of a negative number, turn it into some big number or something. There's a bunch of ways to handle it. But essentially kind of the same kind of format where you just add something to mark it as visited it. And you can obviously modify this back to the original numbers. That's the other thing. Is yes, you are modifying input, but if you really wanted to, you can turn this array back into the original thing. Just by saying if the number is bigger than c, just subtract c from it, and then you'll get your original input. So, but yeah, it's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you next one. Thanks for watching.